quick tool to actually find out all the Gleason
Uh,
related.
Jack,
Yeah.
I'll just give Luz some brief of what you're doing.
Fine.
I sent him the Gleason score documents,
Okay.
and we're trying to parse them.
Okay. So go ahead. I'm going to go ahead and first of all, I'll analyze the document. You can see that with the rule I created, then we'll drill down into it. We're able to here get all the Gleason scores and their various types of values on this page. Okay. And how this is a top level annotation rule. And so why don't we start by drilling down, or actually starting from the bottom, working our way up. We start with a dictionary, okay? So I'm going to open up the grading types. This dictionary has one value in it right now, this Gleason score, okay? I put in an extra column here called Gleason in case you wanted to add in the future different types of scoring. All right. So if we go inside, double click on this, we see that this has a number of different surface forms. Okay. These are the different ways it could actually show up. So you have one dictionary entry with a number of different surface forms to cover the scope of what you plan on seeing. All right. So we'll go ahead and close that. Once we have that, okay, I created very simple character rules, as you can see from this, okay? So we have different character rules that can cover all the situations that I've seen so far, as you can see with these right here, okay? A straight decimal number, okay? Once we have these character rules, we can build this into a parsing rule, okay? And this is the general annotation. So I'm going to bring up the one that we're looking at right now, GS0, and we can see this is the breakdown of it. Okay, so what it is, I'll collapse it so it's a little easier to see. Okay, so what we have is we have an annotation rule that is looking, this is the breakdown, this is what it's looking for. Okay, we have a grading type dictionary entry that we're expecting at least one of. That's what the check mark means. Okay, we're expecting one and only one of those.
Yeah.
After that, we may get different types of tokens. And then by the tokens, I mean, I'm looking in particular for prepositions. All right, part of the is preposition, meaning Gleason score of, Gleason score between, those kinds of things. Okay, and I expect it to be lowercase and alphabetic. All right, and I put a limit on there so it can occur either 0 to 3 times. All right. The next element here is actually a group, and you notice here it says disorder. It means everything within the group, it can occur in any order, it doesn't matter. And here, Lior, is where I mentioned to you before that this particular tool, I'm not sure how it goes into the CAS, which is a common annotation structure, but this tool does not allow any sort of exclusive OR. Okay, so the workaround that you have to do is everything that you expect might occur, you put within this disordered group, and each one you give this, it can happen either once or none. Okay, so in each case. In this case, it's a simple token that I expect to be numeric, or it could be something that looks kind of like this.
Yeah.
Something that looks kind of like that. Something that looks kind of like this. Okay.
Yeah, and when you're using this kind of feature, 6 equal 3 plus 3, it knows that it's integer, equal sign, integer, plus sign, integer.
Well, let me show you. It's yes. The short answer to that is yes. But let's go ahead and look at these character rules again. I'll open up one so you can take a look at it. Let's take a look at the first one. Okay, so here it is. We have a decimal number. 0 or 1 decimal numbers at the beginning to cover us another case that shows up. 0, 1 space separated. So in other words, something like this, it would handle it if there was a space in it. You can see it still highlights it. Okay, so it handles it with or without a space. All right, and that's basically how it goes here. Now over here in this group, I have these punctuation, like it could be expecting a connector punctuation in this case It could be like a dash. No, in this case, sorry, an underscore, because there's one example here, this one right here. This one underscore right here, right, underscore 7, that's connection punctuation, okay? And
Mm-hmm.
it could also get an equal sign, as you see over here. It's easy to see my cursor when I'm moving around.
Yeah.
Okay, great. Okay, so again, we have the optional space separators all the way through, and that's the what it's looking for in a particular character in a character rule. Okay, so that is within. Those are all within this top level composite rule. Okay, in this group, so I'm expecting one of those. There's only actually 3 that I'm using, even though it showed 4. The only 3 that I actually need to use, because another one I found that was just basically an overlap. So you try to get rid of anything that's overlapping. Plus a numeric. Okay. Now there's another case that might occur, something like this. Okay. So in other words, this one right here is kind of like that case. Gleason score of 7 to 8, 7 or between 7 and 8. Okay. So
Yeah.
you would need another kind of rule to cover that. All right. And so, uh-oh, what happened? There's GS1. Okay. So this one, GS1, we can take a look at it. It's what you might expect. This is kind of the hard-coded version of this, of dealing with more than one value. Okay. So we have a single grading type. We have the same token we had before. That's 0 to 3. Okay. We have the first group, okay, that we are expecting, this value right here or this value right here, okay? And then after that, we have a token whose value I decided to make as a regular expression. I'm expecting just these 3, okay?
Mm-hmm. Yeah.
One thing about this particular program, Content Analytics Studio, the regular expressions are very limited. I've tried to put some rather complex ones and it just kicks them out. It crashes. I don't know why. And none of the people at IBM will either. So if you have to use regular expressions within your features, they'll have to be, in this case, using this tool will be simple. Okay. So and or 2, and then a second group. Now, the ideal situation is to be able to actually combine the 2. In other words, be able to handle both this and all of these in the same rule. That has a lot of gotchas. If you try to combine too many things within a single rule, you're going to run into problems because you'll start getting noise. Okay, it'll start picking up things that you wouldn't expect.
Mm-hmm.
So I'm going to go back to here and I'm going to turn these rules off. Why? Because these 2 rules interfere with this third rule here. Okay, and there's a way to get around that, but it's not within the scope today. So I'm going to go ahead and recompile these. We see GS2 picks them all up. Now let's take a look at GS2. Okay. So we have our token and our first group. And then we have this second large group, which is made up in itself of another group. And this star, this asterisk, means it can occur 0 or more times. Okay. And here we have that and, or 2. And then simply another group like we had above here, another disordered group. So it's able to handle, in other words, I should be able to put and 7/8, and it should handle it.
Yeah. Mm-hmm.
Okay. So that's in a nutshell how that works. Now, there are many different kinds of rules. You have in the scope of the rule types. You have phrases, and you have entities, and you have aggregations. I don't know if it's really the scope to go into those things right now, but they work over. See, all these rules work within.
Is there a way to tell him what is the match? What is the value that we want to extract here, or is it just the
yes,
entire
there is.
section was? Is there a way to name each catch?
You mean? I'm not sure what you mean. In other words, you want to take a particular example like this one. Okay, you see that the covered text is Gleason score 7 = 3 + 4, right?
Yeah.
Now, if I wanted to, I could make a I can make what are called features. All right. I can make a feature. If I drag this up into here, I'm going to call it F1. And I'm going to take, no, I don't want to use that one. Let's just do the simpler case. Delete feature. I'm going to take from this group. Go over here. I'm going to call it F1. I'm going to take this one, call it F2. This one, F3. This one, F4. Okay, so now if we recompile this, so gotta save it first. Save, recompile. Okay, so we'll go GS2, and we go here. Now you can see right here, F1 and 2 didn't work. Why?
Yes, so you're expecting that F1 will be listen score
Well,
and
no,
will
in this case, yeah. In other words, it would be whatever those character rules was for this. You understand?
yeah.
So, and then on top of that, I would take these 4 and concatenate them into a concatenated list. So all of them will be blank except for one, and you get the one you were interested in. You understand what I'm saying? So if F3 was equal to something, all you would see is the F3 value, even though they're all concatenated together. Okay, and that's how you get a composite thing. And from there, you can continue on and codify it and normalize it. Because, for instance, I know that GS2 is a Gleason score that I'm expecting a certain character type from. So from that, later on in post-processing, I know what to expect in the character, given the character rule, the character type. All right.
Yeah.
So I can parse it down and say, okay, this is equal to 7. This is equal to whatever normalized value I want to get in the end. Okay. Are you following me? Okay. So one of the caveats that needs to be understood about annotation rules is that they're of an additive nature, meaning that a rule fires when a condition exists. All right. If you have a situation where I put together a rule that was by mistakenly giving me this before, okay? I fixed it since then, but let's say this is a rule that I had and I didn't know really what to do with it, because you can set conditionals on a rule, but it only will fire if it contains something along with. So if I go to here, oops, no, that's not what I want to do, sorry. If I go to add precondition, you set the scope, it doesn't really matter. You say, okay, I know that if GS1 fires, okay, with a particular value of such a value, it will be the other value will be fired as well. In other words, if I set a condition for GS2 that GS1 has to fire, GS2 will only fire if GS1 fires. Are you with me so far? Okay. There's no way to do the opposite in a straightforward manner. In other words, I say, okay, I want to fire this rule, and it can contain up to 2 scores, but only if the second score is not, let's say, a date. Okay? Yeah. These are all dates. So it can contain up to 2 values and not a date. And one of those values can't be a date. You can't do that directly. You have to set up another circumstance of expressions, which can be done, but it's not straightforward. So just understand that as a caveat, okay, when rules are actually being created. Okay? Questions so far?
Yeah, so this can we work with this but in a way that the user will set those rules only by typing the trigger and match? I mean, is there an easy API for Watson that creates these beautiful rules behind the scenes?
Okay. Short answer is no. Okay, the rules have to be created a priori. Now, what happens with those rules, and in other words, you could actually analyze a particular page, a particular document like this, yeah, and then send the results of that annotation to a database, a relational database, and at that point, you'll know what kind of annotations are in a given document, and then present those to the user to select if they want. Is that kind of what you're talking about? In other words, I noticed when you gave me the demonstration of that, it gave a whole list of different kinds of things that the user can click on to refine the search, correct?
Yeah, that's right.
Okay, but I mean those choices had to come from somewhere. The user doesn't create those choices, right? Or do they?
Actually, he
They
do.
do.
He
Okay, in other
only
words,
the only thing that he gets that he starts with is the a list of documents, and from the list of documents he can filter out those documents based on some keywords,
okay.
and then moving uh, one document at a time, he teach rules based on those documents.
Mm-hmm. Mm-hmm. Okay,
So
I understand. This section of the content analytics, okay, deals mainly with pre-prepared rules in order to be able to pull out the knowledge that is expected beforehand.
mm-hmm.
Now you can see a stage where a system would get complex enough that it would have all conceivable medical notions built into it. So again, if you start with a document set and you have it analyzed, assuming that it has a non-exhaustive set of information beforehand, it will give you all the choices that a user could possibly be looking for.
Yeah,
It will not get something new in like this unless it's part of a dictionary, and the dictionaries have to be created a priori. Now, the only other way around it is again through machine learning, which is a different mechanism than this
approach.
is. Yeah.
Yeah.
Okay. But I mean, this is one thing that because I would think that you would quickly come to a kind of a plateau representing the body of knowledge that is needed for such a system to act on its own from the beginning. And then anything added to that could be added on top of and made learned by a machine learning process. Okay. I am, but again, the purpose of me showing you this is to understand that one thing wasn't clear to me. If a user has a set of documents and he says, I want to look for some exotic thing, right, that he suspects are in the documents,
Mm-hmm.
he says, search for this exotic thing, yeah? And then are you saying a model is automatically built and a regular expression is already automatically created? Is that correct? Is that how it works currently? More or
Yeah,
less? Okay.
that's right. Every document the user teach adds some it reflected in the regex that being built.
Okay. 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 So that would be one of the caveats about this is it does not support like a runtime addition to the dictionaries. It works on the dictionaries that it has. Okay. So that's the main caveat at this stage. A later stage, like I said,
Yeah,
would
but
be
can you build the dictionary on the fly?
no.
I
That's
mean,
the thing. They have to be compiled in. They have to be compiled into the cast. In other words, when I go ahead, I do something like this to export. Okay, I export if I had one set up, which I don't, to a kind of analytics server, and you pick a particular pipeline to send to it, and everything is compiled and sent to the server. Okay, it's a closed box as far as that's concerned after it leaves this tool. So for the approach that if it's something that you can start with a large knowledge base, okay, um, one way to go is this scheme. If you have a large knowledge base and then bolt on to the end of it some sort of way to add to it, okay. I'm not convinced that this is the best way to go. I mean, I think that a graph approach would lend itself very, very well to a machine learning approach, at the same time being able to be given a large knowledge base from the start. Okay. What
Yeah.
this allows, which is kind of nice, is let me just switch over to this other document, which is from a project I was working on. Okay. I'm going to go ahead and analyze this document, not with this one. Okay, as you can see, it generates a whole lot of different things. Okay, so let's take a look. Let's take a look at where it found an award. Okay, direct cost for the 2-year period may not exceed $275,000. So what we have is not to exceed, which is normalized to max award, the actual value and so forth. Okay. So what you're able to do in this scheme is actually normalize values. If I click onto this one, let's say this is an, okay, this is a situation where you have eligibility. It's a restriction. Okay, eligibility type is restricted because of the are not eligible parts. Okay, and then what is restricted? The types that are the types that are restricted are non-domestic entities in this case. Okay, yeah. So it has its advantage of being able to take the unstructured data and through a normalization process, get it into a regular database of structured data in order to make decisions based on it. That's an advantage, okay? But as you can see, lots and lots of different rules need to be created to handle the different circumstances. And I don't know what the depth, body, and breadth of the kind of things to be expected in a pathological thing, but I imagine it's very broad and lots of different things. Plus you have individual physicians, etc., doing, writing in their own styles. So that's another area where it may be advantageous, but it's also very complex. Okay.
Yeah.
Now, like I told you before, I'm a big graph database fan. I think they're great. All right. So here we have a graph database that has this is the metadata in there, the different labels in there. Okay. Mainly we have topics. All right. This is what I built at the beginning, okay, as my knowledge base to compare, to do the reconciliation between funding grants and researchers. So if we take a look, I just show you how many. Count. This is the number of nodes in the knowledge base. Okay, and there are duplicates, but the duplicates aren't just straight duplicates. The duplicates have different paths associated with them. So you might have a number of neocortexes, but they may go to different parents. And that in itself is an important thing to try to build in the fuzziness that you want to build in to an analysis to see, okay, I have more things that seem to be connecting me to this particular node's parent rather than the other neocortex's node's parent. You follow what I'm saying? So you have shades of meaning that you're able to pull out of it by having a number of different paths to parents from the same, what appears to be the same thing. Now, if you look down here, I'll click on it. Let's see if I can find two of the same type. Here we go. These two. Okay. So you have this, you see this number right here, this big long number right here. Okay. And then click this one. You notice they're different. Okay. They have the same parent at 500 right here. Okay. This 500. Yeah. So that's their relation point. And you can get a lot of meaning from that. Okay. So let me just show you a couple of other, graphs that I prepared already. Okay. This is simply a graph of, oops. These are the yellow are are researchers, and the blue are the topics that they are related to based on an analysis of their research paper titles. Okay, and I chose to make the in this case full count match greater than 2. I wanted to have something. If it's a full count match, I know that it matched exactly. I have a confidence of 1. Okay, so in other words, in three different papers, Raman spectroscopy showed up. Okay, so we can see from here that this is a higher weighted one. There are more things with Michael Rosenbloh that he does that's related to spectroscopy. Now, of course, you can add in, the date of publication, so forth like that, and get further meaning. It may be something he was interested in 10 years ago, but may not be now. Okay, so that's another issue.
And other than the count attribute, are there any other types of relations, or is it all the same relation?
Well, this particular relationship is what I call has affinity. Okay, it's simply the relationship between the researcher and the knowledge base that's in the system as it is, all these blue ones, Okay. A comparison to that. Now, the idea would be that the researcher, and this is where it ties in to be able to do a free search, okay? If the researcher or whomever using the system types in a new value and it's not in the graph, then obviously you add it to the graph. Okay, and you try to relate it to something that's already there. So that's how the Kiilu supervised learning might kind of occur, but it's not really learning, it's just adding to the graph. But in addition to that, if there is an analysis of these documents as it is, they should be analyzed regardless of what the user is searching for. They should be analyzed as it is. And if it finds new stuff in there, it should somehow be added to the system, because that's a free lunch in a way. Okay, even if the person's not looking for a particular relationship that exists inside these documents that you have, these pathological documents that you have, you should still analyze it and try to find topics, for instance, to add to the system. That would it would seem to me. Okay, let me bring up another. Oops, let me bring up another one. Here, this is where I actually go ahead. Maybe. Okay. Okay. So now we see, I took the researchers, I related them to topics, and then those same topics I related to calls for proposals, research grants. Okay, and again, I wanted a full match count greater than 1, etc. And we can see here, let me zoom in a little bit more. And okay, these 3 are all the same visually, but they're different values in the knowledge base, because in this case, they come from 3 different lists. Okay, so all these solar energy and so forth. Let me bring this down a little bit, this full match count down. Actually, let me just go ahead and do this, but I want to limit it because it will return too many. Let's see, 200. Okay. Now, 200 is actually too little because it's only returning 1 researcher, but we can see that it's coming up with partial matches. We got gene expression profiling, gene expression regulation plan. I have no idea what those are, but these are other things that it found, but with a less than 100% confidence. In other words, it was only a portion. In other words, I suspect it found gene expression within it found 2 within the 4 of this engram. This is an engram of 4, okay, and it found gene expression. So it's likely that the confidences in each of these cases are 50%. Okay, that's my guess that they're 50%. All right, in this case, you can see right here, confidence is 50. So it's only finding 2 of those. Okay, but again, these things, the more that goes into the graph, the more it goes into the topic knowledge base. Obviously, the better we're going to have of a match and less noise. Okay. Questions. I see this as as one of the ways we really can get an expressive way of returning the data that the user is looking for. Okay.
Mhm.
In the case of the UIMA, that may have its uses on things that I don't know, if you're going to have a priori have a bank of things that the user can select from before he makes a particular search request. In other words, you can already come up with, have a box like Gleason and so forth. So you showed me, Lior, you showed me when you put it in, again, when you went into the NLP studio, you
Mhm.
analyze, you trained it, you trained it explicitly. Right. Now I remember. Yep. Okay. So it was explicit training beforehand, and then as a result, it returned the things that it found, and obviously the things it didn't find that you had to add later on. Same thing with this, more or less.
Yeah.
Okay.
So
But I see it. Sorry. Go ahead.
yeah, again, our main challenge here is to give the researcher the ability and the power to do things on his own. So
Mm-hmm.
you're right that we can compile content out of the box that will pull Gleason and will pull every other known value, extract any other value that we know at the moment.
Yeah.
But if you really want to give the researcher the power to say what is right for his research and what is wrong,
Mm-hmm.
uh, we
Mm-hmm.
need to to create some UI and create some mechanism that will create rules
I, I,
on the go and not
mm-hmm.
ready made. So
Yeah.
that
I understand and I agree with that. I mean, so the question is, the method that you think would be the way to go in order to set up the machine learning of it. Okay, well there it is. There it is.
yeah, but we are open to to check other technologies and to see if they will allow what we're looking for.
Well, yeah, I
Um,
mean that I think is But again, I think we not only that. I mean, look, it, a user's gonna a user's gonna want to use the system as a discovery tool as well.
that's right.
Okay, and that's where I think where the overall model I believe is graph like. Okay, in order to return not only what the user actually asked for, but to return a hit if there's a hit in the documentation for something you didn't ask for, but it's related with a certain amount of confidence. And that's where I think the beauty of it can be. Okay. The researcher may get everything he or she asked for, but in addition, he gets because there's some sort of a interesting connection or interesting path between his search result, right, or search query,
Mm-hmm.
and a node somewhere that is related. And it could be a node somewhere that's related not only to his current search query, it could be something that's related to this particular user's history of them. Okay.
Mm-hmm.
So that's another thing. I assume there should be a user history. When a user comes out, you should have some sort of a history of the kind of queries he or she makes.
Yeah, but this kind of stuff you can do even without the graph database, but just by based on usage or previous searches.
No,
Uh,
that's fine. But what I'm saying is he's looking for Gleason right. He wants to do Gleason right now. Okay. But I know his past search said looked for PDA. Was it PDA, BDF, whatever that other value is? I forgot what the other value was. What was it? And PSA, right?
Say, yeah.
All right. But in the past, he's also looked at PSA, and you'll get in addition to that, something that has a high correlation between Gleason and PSA that may not have come up if this was the first time he looked for Gleason. You follow what I'm saying? But in the past, he looked for PSA. So Gleason and PSA may mean something else that he never considered.
Yeah.
Okay. In this case, obviously, probably not the case, but you know what I'm saying. Again, making the discovery of a relationship that was not expected. And I think that's where the real power of the graph comes. Regardless how you get it into the graph, whether it's some sort of machine learning technique or otherwise, that's fine. But I mean, the real power of the graph itself is maintaining these kind of relationships, and you can have any kind of value in the relationship that you want. So there it is.
Okay, that's interesting.
Okay.
Yeah, that was cool demo.
Okay, great. I'm glad it was clear enough to you. Great. So, any other questions? I understand I'm supposed to meet with you guys on Thursday. Is that correct?
I think you should have another meeting with Moran.
Okay.
Right?
Yeah, that's right. And what type of meeting is this?
Moran is currently functioning as our HR person.
Okay.
So I guess she will also interview you about the thing that she looks for in a new employee.
Okay.
Okay.
I mean, but other than that, are you prepared to make me some sort of an offer?
I guess after she's going to meet you, and if everything going to be good, also for in her eyes, I guess that's the next step. Yeah.
Okay. Okay. Very good. Very good. Well, I hope I shed some light on things, a little bit of light at least. It's a fascinating field, and it's so open ended that it's wonderful in that. So, well, great. So we'll be in touch and
we'll be in touch. Thank you very much.
Thank you. Okay.
See you soon.
Okay. Take care.
Bye bye.
Bye bye.